Parametric equations are equations that link x and y via a third variable, usually either a t or a theta. So you start with two equations, x as a function of t and y as a function of t. You may be asked or need to find out where the curve crosses the axes or another line. So if you're trying to find where it crosses the x-axis, then obviously that's when y equals 0. So you use that to solve and find t and then substitute that into x equals a function of t. Similarly, if you want to find where it crosses the y-axis, that's when x equals 0. Solve and then substitute that into y equals f of t. So if you're doing it to find where it crosses a line, you'll need to substitute for both x and y, then solve for either t or theta, whatever type you've got, and then at the end, once you've found your solutions for t or theta, work out what the corresponding x and y values will be for each of those solutions. So for the x-axis, we've got y equals 0, which means we've got t cubed minus 9t equals 0, and factorising that gives us t squared minus 9 equals 0. So that leads us to t equals 0 or t equals plus or minus 3. So what would the x values be? So when t equals 0, x equals minus 1, and for t equals plus 3, it's going to be 9 minus 1, which is 8, and you can see that it's going to be exactly the same even if it was minus 3. So those are the coordinates, minus 1, 0, and 8, 0 for the x-axis. And then for the y-axis, we've got x equals 0, which means that t squared minus 1 equals 0, which means that t equals either plus or minus 1. When t equals 1, we're going to have 1 minus 9, which equals minus 8. And for t equals minus 1, we're going to have minus 1 plus 9, which means that's going to equal 8. So in this case, we're going to have 0 minus 8 and 0, 8 as our coordinates for crossing the y-axis. So now let's look at the line. So the line equation is 4y equals 5x plus 5. So we're going to substitute in the t forms instead of the y and the x. So that's going to give us 4t cubed minus 36t equals 5t squared minus 5 plus 5. So we can see they cancel each other out. Now let's bring everything over to one side. So we're going to have 4t cubed minus 5t squared minus 36t equals 0. Let's factorise out a t, and then we'll have 4t squared minus 5t minus 36 equals 0. So t equals 0 is the easy one. And then if you use your quadratic formula to solve the other one, then you'll get t equals 3.69 to 3 significant figures, or t equals minus 2.44. So when t equals 0, x equals minus 1 and y equals 0. So that's our coordinates there for that first one. And then with the help of the calculator, x becomes 12.6, y becomes 17. So that's 12.6, 17. And then for this one, x becomes 4.95 and y is 7.43. So that's our coordinates for that point there. It's also quite common for them to ask you to change the parametric equations back into Cartesian equations. Cartesian equations is the name for the ones that you're most familiar with, the ones that are in just y and x. For the first method, you'll take t and make it the subject in either the x or the y equation, whichever works best, and then substitute this into the other equation and hence eliminate the t. The second method is if you've got trig functions involved, then you're going to need to use an appropriate trig identity to eliminate the theta. So here's an example where we're going to try the first method. We've got our two parametric equations. We want to end up with just y equals some function of x. So here we're going to start and focus on this one here. So rearranging that, we'll get t squared equals x plus 1. And therefore t would be the square root of x plus 1. So we're going to substitute that into the other one. Now you might find it helpful to think of this version in this format. Okay, so then that gives us y equals x plus 1 to the 3 over 2 minus 9 x plus 1 to the half. Okay, and if we factorize out x plus 1 to the half, we'll get x plus 1 minus 9, and so altogether we've got x minus 8, x plus 1 to the half. Now we're going to try one where we've got to use the trig functions to eliminate the theta here. And because we've got cos 2 theta and the other equation only uses cos, the identity we're going to use is the double angle formula. So cos 2 theta equals 2 cos squared theta minus 1. So rearranging the first equation, we can get cos 2 theta equals y plus 4 over 3. And then with the other equation to get cos theta, we'll get cos theta equals x minus 2. Now we're going to put those into this identity. So we've got y plus 4 over 3 equals 2 x minus 2 squared minus 1. So let's multiply through by 3 and then move the 4. So that's going to give us y equals 6 x minus 2 squared minus 3 minus 4, so that's going to be minus 7 altogether. And then if we expand that, we'll come to 6x squared minus 24x plus 17.